Let's look at an example involving volume and temperature. You purchase a balloon from a local party supply store, which keeps the store temperature at 62 degrees Fahrenheit. Your cashier explains that the balloon is filled with 2.5 cubic feet of air. Later in the day, you realize you left the balloon in your car. When you retrieve the balloon, you note that the temperature in your car is 110 degrees Fahrenheit. How much has the volume of the balloon changed? We could use Boyle's law here, but again, I believe it's easier to just have one formula, the general gas law. Pressure times volume over temperature equals pressure times volume over temperature. Now in this case we're using temperature, so we have to remember something important. This is absolute temperature. That means it has to be in either Kelvin if we're using Celsius or Radian if we're using Fahrenheit. Generally in the US we use Fahrenheit, so we're going to work with that. To convert from Fahrenheit to Radian, you simply add 460 degrees. So temperature 1 at the store is 522 degrees Radian. Temperature 2 is 570 degrees Radian. The volume of the balloon is 2.5 cubic feet of air at the store, and then we want to know what it is in the car after that temperature is increased. Pressure isn't really an issue here. At the store and inside the car, the pressure is going to be pretty much the same. We're on the surface. So we just need volume over temperature equals volume over temperature. And we're just going to plug those values in. So we're going to have 2.5 cubic feet over 522 degrees Radian equals the volume we're trying to find, the volume in the car, over 570 degrees. We want to get the volume alone, so I multiply that denominator on the right-hand side, the 570 degrees, to the other side of the equation. And that gives us 2.5 cubic feet over 522 times 570, which equals the volume of the balloon inside the car. Now we can just type all that in the calculator. If you notice, we're going to have Radian on top. When we multiply, that goes on top. Radian on the bottom, so those units cancel out. So I will just have cubic feet left over, which is what volume should be measured in. So we're going to get the volume in the car equals 2.72 cubic feet after we just plug those numbers in the calculator. That roughly 50 degree temperature increase results in an almost quarter of a cubic foot increase in volume.